Welcome to 5G Technology World. I'm site editor Martin Rowe. Today we're speaking with Danny Singh from Qualcomm, who's going to explain to us about 5G NRLight. 5G NRLight will be part of 3GPP Release 17. Release 16 is pretty much finalized at this point, and now 3GPP is moving on to Release 17. So Danny, tell us about 5G NRLight.
Sounds good. So 5G NRLight, it's a new technology that's coming with the third 3GPP 5G NR release, and the point of the technology is really to help scale 5G to the right level to support a broader range of IoT devices. If you think about 5G today, that's deployed globally, it's very much targeted for smartphones, laptops, so very high performance, enhanced mobile broadband devices. Then the second release, release 16, which is the one that's getting finalized, is being standardized as we speak. It's focusing on even higher end devices. If you think about industrial IoT factory automation, so it's really scaling up in terms of performance, the ability to support lower latency, higher reliability. And this third release that I mentioned with a focus on 5G NR-Lite is then look at the gap that is between what we have today and what's going to come tomorrow, which is even higher performance devices, and address those use cases, things like wearables, lower tier smartphones, sensors, asset trackers. So things that aren't quite, that can't really be efficiently supported today. Is going to get the flavor of 5G, the 5G that's coming in with NR-Lite, that's going to be much, much more efficient in terms of, network efficiency, power consumption, the amount of bandwidth you need. That's going to be what it's going to be used for.
So what is it that is going to be different in NR-Lite? Usually when one thinks of light, we think of something scaled back, that we don't need all the performance that we had before. So what is going to be different about NR-Lite versus what we have today? And when you say NR-Lite, are you referring to release 17?
Yes.
By that? Okay.
Yes.
So tell us about what's going to be different in NR for release 17.
Yeah, so it's really looking at devices that doesn't require the 100 megahertz of maximum bandwidth that's defined today with NR. So if you think about things like wearables, you're not constantly sending a lot of data. You're not really streaming Ultra HD video to your watch or to a wearable. So then efficiency becomes the utmost importance. You really want to be able to support many more devices in your network at a much higher efficiency. So in terms of NR-Lite, there's really 4 areas of enhancements. And when I say enhancements, it's both making things more efficient, but also, I think it's also bringing kind of new capabilities. So if you think about the first of the 4 is lower device complexity. You want to be able to fit in your fit 5G NR, whether that's the RF front end or the modem, into a much smaller package, right? A smartwatch is much smaller than a smartphone. You want to operate it at maybe 10, 20 megahertz of bandwidth versus 100. You also want to reduce the number of RF chains that you have, so it's lower complexity, lower cost, and many of these devices only needs to be half duplex, for example. It doesn't have to be full duplex, so you can actually be more efficient that way. In terms of power consumption, there are enhanced power modes that's coming. Actually, power enhancement is something that's continuous gets introduced in 3GPP releases. So there are power saving features coming in release 16, but also 17, where you will have power modes that allows your device to stay in low power much longer. You could actually also reduce the output power of your transmitter, so you could save power that way. The third area is on the network side. Again, supporting half duplex to full duplex, all within the same framework to be very flexible, supporting different type of devices. There's a reduction in control signaling, for example, so that your device doesn't have to send a lot of control signal, a lot of overhead before actually transmitting actual data. And then the fourth area is coverage. So of course, with lower power transmission, with a single receiver, you are going to have some impact in terms of how much coverage or how well your device is going to be able to stay on the network. So there are techniques that are being introduced here to kind of recover some of that coverage loss because of the lower complexity. So there are things like frequency hopping, there are repetitions, bundling of frames. And also we're looking at things like relays and what we call side link, which is the ability for a device to talk to the next device directly without going through the network. And that's a technology we are using today in other contexts, but not so much in, let's say, IoT or wearable type of communication. But in Release 16, for example, CV2X, which is the ability for a car to talk to other cars, you actually leverage this type of side link or direct communication. So it will be compatible with what's been deployed today. So a lot of the NRLight features are implemented, both, of course, both on the network and the device side, but a lot of the complexity reduction, a lot of the power enhancement, they are done on the device side, just because you are designing into a smartwatch or a sensor. On the network side, it's compatible. You will have to, obviously, when you migrate from release 15, 16 to 17, there will be upgrades, but it's not something that's fundamental that you will need new hardware. We see NRLight as more of a sub-6, sub-7 gigahertz technology, mainly due to the bandwidth. You don't really need to go to the millimeter wave for the 100 or 400 or 800 megahertz, right? So I think the whole point is operating in 10 or 20 megahertz of bandwidth. And to that, so you could operate in a very low band, meaning sub 1 gigahertz, or you could leverage 3.5 gigahertz, the mid band that's being deployed today for 5G. So it's more of a lower spectrum band use case.
Are there any effects on the wired side of the network?
I don't believe there will be. It's more of a phi mag, a lower layer change. So more on the device end. I think on this again, NRLight in release 17, the work is still yet to begin, right? So I think the discussion is still to be seen of what changes will need to happen across the entire end-to-end 5G system. But from experience, I think many of the changes on the upper layer will be for better efficiency on the network management part of things. So I think it will definitely be more of a software change, if any, versus let's say we need a different functional unit or things like that. So yeah, but it's, again, a lot of these technical details are still being worked through. I mean, we have our work that we're doing in our engineering R&D. But the industry is getting together to kind of define this NRLight. I think what's being agreed upon so far is the scope of, hey, here is where we want to get to. Here are kind of the rough design goals, which is, like I mentioned, the lower bandwidth, the improved power and things like that. But exactly how this will get implemented in the system, I think that's still to be realized, to be seen.
You mentioned the possibility of even going below 1 gigahertz. How does this differ, and in what applications might work better with 5G versus using the LoRaWAN technology?
Yeah, so that's been actually a topic we've been quite vocal with, not in the context of NRLight, and I can kind of explain why. So if you look at today, these low power wide area, they call it LPWAs. So things that are delay tolerant, the device has to be very low complexity. Today is being addressed by really these two technologies called narrowband IoT in the sense of 4G, and also what we call eMTC, and some refer to as LTE-M. And narrowband IoT is a 200 kilohertz bandwidth device or technology, and the eMTC or LTE-M is 1.4 megahertz in terms of bandwidth. So these are very suitable to address the same type of the use cases that LoRa and some of these non-3GPP technologies is doing today. And because it is a release 13 these are release 13 technologies, meaning they are part of what we call LTE Advanced Pro. But as we go into 5G, these are actually getting brought into what we call the 5G platform. So these are compatible with 5G, the new 5G framework. And actually what happened in release 16 is that LTE, what we call LTE IoT or narrowband IoT and eMTC are enhanced in a way that they can now be deployed in 5G carriers. So they're in fact the 5G, what we call the 5G IoT solution. So if I were to kind of compare these LPW LoRa and these two, a 5G solution or LT, so they're more comparable to narrowband IoT and eMTC. And if you think about NRLight, it's more of a step up. You have 10 megahertz, 20 megahertz of bandwidth. So they will address a higher performance use case compared to those.
Getting to the power management, how is that going to be implemented? I realize that's being done on the device side, but what sort of techniques are being implemented, and what do engineers who are going to have to design these need to know in terms of how much of this power is sort of under software control versus under hardware control, and with power always comes cooling. So I'm wondering if there's anything that we need to address in terms of cooling to maintain battery life. That's the ultimate goal from all of this.
Right. Yeah, no, that's a great question. I think if you're a engineer or a design engineer who's designing a system with whether that's NRLight or narrowband IoT or any of these 3GPP technologies, all the lower power operation, they're done as part of how the device communicate with the network. There's nothing that you need to worry about. Whether now that I have, for example, now that, if I have to kind of put the device in low power mode, it's something that would just be done through the communication of the device and the network. So some of the things that are coming for low power devices, for example, is reducing the amount of communication you need to have the network to the network, right? So you could actually stay in low power mode for much longer. And then on the question, I guess, on the cooling, these again are very, they're not that high performance. If you think about 5G today, you're looking at gigabits per second. They're not going to be in that range. The amount of processing is much simpler. You're not going to have too much. Yeah, I would say you're not going to have too much thermal type of concern, just because you're not operating in the range where you're kind of pushing the throughput or performance. You're really operating in this very comfortable 10, 20 megahertz, tens of megabits per second, maybe 100 megabits per second range, and that's the thermal profile that's very well understood today, right? Our phones with LTE phones today, or they're operating at higher throughput than that, and there's not much thermal issues there.
Okay. Will these IoT type devices use a different modem that doesn't need all of the capabilities that an EMBB type of modem would need? And again, usually it's because you don't need the complexity and you want to reduce power. So what is Qualcomm doing in terms of that? Will there be a sort of a separate path of devices, hardware that
Right.
go into these devices? Will that be different?
Yeah, I think that's to be expected. If you think about, obviously, we don't have an NR-Lite product. There's no announcement. This is, again, very early in terms of technology standardization and development. But if you look at history and how we have rolled out products for, let's say, narrowband IoT or eMTC, these are completely different chips from our, high performance, high tier Snapdragon modems, right? So they are very specific to the and specific and optimized to the task that they're supposed to do. So they, again, they support up to 1.4 megahertz of bandwidth, right? They don't go up to 10 megahertz or 20 or even 100 megahertz. So the hardware is optimized for that use case. And in terms of, obviously, the cost efficiency, the commercialization aspect, you kind of have to do that, because you can't put a full-fledged modem in every temperature sensor that you're going to deploy, right?
Right.
You kind of deploy what's right for that use case.
A single antenna, a 2x2 array, a 4x4 array. What do you anticipate for these kind of devices?
So for NR-Lite, we're looking at single/dual antenna. So they will likely not support any high order MIMO, because they don't need to. You don't need the layers to get to the throughput, and it's much easier and more cost efficient to go with the single antenna.
That was really all that I had. If there's
Okay.
anything else that I've missed that you'd like to add, go right ahead and we can stitch it all together later.
Sure. I think for NR-Lite, that's I think we talked through quite a bit of detail. It's really at the we're just starting to work through the details with the rest of the ecosystem. I think release 17 work is starting shortly after release 16 is complete, which is going to be in a few weeks' time. I think how we see NR-Lite evolving, and why there's NR-Lite in the first place, is we really see 5G as this unifying connectivity platform that will ultimately connect everything. So today we have a couple of different technologies in our toolbox, but what the evolution of 5G is going to give us in the next 10 years is that it's going to continue adding these new tools into the toolbox, NRLight being one of them. And we do see that in release 16, 17, even 18, 19, 20, we're going to see more new things coming into this platform that will address different parts of this this ecosystem. And I think that to me it's quite interesting, because 5G, a little different from what 4G was kind of originally envisioned for. 4G was envisioned for data, and really nobody really thought about 4G being used for anything else other than phones. But 5G was kind of envisioned to do much more, and a lot of the foundational work, the foundational technology that was defined in part of release 15 has paved the path for these incremental improvements, new technology coming to the platform and allowing them to work very seamlessly. So I think, yeah, NR-Lite is great. It's going to address a certain niche of the need of the 5G world, but many more to come.